number is 1.35. This number is 0.65. Okay, and this number is 0.834. This number is 1.948. Okay, once you put this in, okay, for column number 6, how do you figure out gate time? Do you see here 2 minus 1? That means column 2 minus column 1. So it's gate offset time minus gate onset time. So 1.35 minus 0.217. That number should be put into here. That should equal to 1.133. 1.133. Okay? 1.133. No, wrong. 1.133. Okay. Stance time, which is column number 3, you see here. Okay, if you don't, you cannot read from here. Here, over here, tell you how to calculate all of them. Okay? So stance time is column number 3 minus column number 1, which is 0.65 minus 0.217. Okay, then put in the number, just get a calculator to do this. Okay? Swing time, which is equal to 2 minus 3. Column 2 minus column 3. Column 2 is what? This 1.35 minus 0.65. Then you put in here. Okay? Number 9, you can calculate the percentage of time you spend on stance space. How do you calculate that? You use the number you got from column 6 and divide it by column, you get the number you got from column 7. You see 7 divided by 6 and then times 100. That's how much time you spend in stance space. Okay, for swing phase, you have column number 8 divided by column number 6 and times 100. So in the bottom here, okay, inside the quotation shows you how to calculate for it. Okay. Strike displacement 5 minus 4. So column 5, 1.948 minus 0.83, and you get the strike displacement. Velocity is column number 11 divided by column number 6, and then you calculate velocity. Okay? So basically you just follow the instruction and do a calculation and fill in all the numbers for table 1. Okay. Now, I show you how to do gate 1. Now it's your job to do gate 2. Okay? So how do you know onset, gate onset, offset, swing onset, and all this? You have to look through the gate 2, which is shown on page 4. Okay, same thing, A to B, B to C. Okay, again, A to B is stance phase, B to C is swing phase. Okay, so you follow the same rule how we did the gate 1. You do exactly the same thing for gate 2. Okay, so you should have no problem. Fill in all this. Okay, the whole table. Okay, do the calculation. Again, I prefer the number to be typed. But if you have difficulty making up the tables, you need to write into it, that is fine. Okay. Now, let's move on to question number 3, which shows how does this subject's percentage of time spent in stance phase and swing phase compare to unimpaired individuals. Remember, this is data from a stroke patient, okay, patient who have stroke. So this patient have difficulties in terms of walking or abnormal gait. So here, the normal subject will spend about 60% in stance phase and 40% in swing phase. I want you to compare that to this subject. And how do you get the number? Here, from the table. Okay? From gate 1, you'll get the number. You will calculate how much time is the patient spending stance phase and swing phase. And compare the number to the normal. Okay? And then, that's not just it. Okay? I want you to explain why. why this patient have this kind of gait. Why this patient spend more time or less time in stand space. Why? Give me a reason. Don't just give me a number. Okay? I need your explanation. Try to say why. What's the possible reason? Okay? Number 3, this answer have to be typed. Okay, I do not accept handwriting. Okay, so type this answer. Number 4, what is occurring on the y-axis when stream 2 or knee angle is selected? Okay, so here, as the y value for knee increase, the knee is moving into flexion or extension. Let's look at here. So let's first look at knee. Either one of them. You can look at the first one, it's fine. A1 is fine. Knee is from stream 2. Okay. So it's asking you, when is stream 2, when the number increase, angle increase, is this flexion or extension? So how do you know? Okay. First, you should refer back to the gait cycle, A to C. Okay. So correspondingly, this is A, this is C. And this part is B to C is a swing phase. So you know from here, this part, you see this big dip here, is a swing phase. Okay. So swing phase is easier to identify. So let me ask you, at swing phase, your knee is picking up from the ground and moving forward. So your knee is moving forward. It's bending and pick it up and moving forward. So this direction, your knee is flexion, knee, right? So the other way should be extension. So when you decrease the number, that's flexion. When you increase the number of your knee joint, that is extension. Okay? So I already tell you the answer for this one. So as value of knee increase, your knee move into extension. I want you to do the same thing and look for hip. Okay? So again, you look for the hip, which is stream number 3. During swing phase here, okay, you see the change? Think about what your hip is doing. Okay, during swing phase, your hip is flexion or extension. Okay, this is flexion or extension, and then figure out if the number increase is extension or flexion. And please put the answer here. Okay? Now, number 5 is to describe the detailed evolution of hip knee angles as the subject progresses through the gait cycle at each phase. Okay? And what is the approximate range of knee angular excursion and hip angular excursion? Okay, so this part, you can get the information from gait, how the hip and knee moves during the gait through the book, or you can look online, you can find information. Okay, I need you to provide description at heel contact, what's going on with hip, what's going on with knee, and mid stance, at the toe off, at swing phase, what's going on. And then provide the approximate range of motion for knee and hip. You can actually figure out knee and hip range of motion from our data here as well if you want to. So range of motion basically is about the maximum and minimum. So you have maximum angle minus the minimum, that's your range of motion. You should do that for hip and knee. Take a break. I'm hot.